Hello and welcome back to Tea Leaves Programming. We're programming like it's 1979, doing Haskell for Dilettantes. When last we left you, we were in the middle of the list module from the NICTA/Data61 FP course. And we had reached this function, seq optional, sequence optional, sec optional, seek optional. I don't know how to say it out loud. And I said we were going to skip it, which we are. But let's go on to the next one, and we'll circle back to seek optional in our next episode. So next we have find. Find the first element in the list matching the predicate. We have a few examples here. So if we pass the function even and a list 1, 3, 5, nil, that should be empty. If there are even numbers in it, it should return one optional value. So it's going to be either full or empty. Let's test out even just to make sure that it works. Pretty sure it will. Even does even just takes a number, right? Even 3 is false. Okay. And even, of course, is not essential to this. It just happens to be the function that the testing here uses. And you can see here that whatever we implement needs to work on infinite lists. Interesting. So does that imply that if we do the naive kind of recursive implementation here, no, it should be fine because we're going to, as long as we return when that predicate returns true, it should return early even if the list is infinite. Let's take a look. Get rid of that. Should I keep making the square hole joke? I don't know, man. I think I've mined that for as much as it's worth. But we can, however, probably continue to use fold right to solve this. Well, you know what? Let's do it twice. Let's make a find and let's make a find too. And one of these, let's see, how would we do this if we were just doing it normally, right? We've got a function, a predicate, and we have a list. Is that correct? Yes. If the list, what happens if the list is empty? If the list is empty, which would just be nil, then we have not found whatever it is we're looking for. And so that's going to return empty, right? I think that's correct. And in that case, we don't need the predicate. I just like always getting rid of these things to silence the warnings and also to remind myself, don't give names to things that you're not actually using. Okay. Otherwise, we've got our list, but really it's not a list. Really, it's some head element and the rest of the list. Call it hood and tail. Normally, so I would like to call these head and tail, but since those might be reserved words, I don't know, are they? Let's see. It's not highlighting them. Maybe it's fine. So if we were doing this, so we're doing this recursively, right? So if, let's see, pred head, then full head, else find pred tail. Is that right? That might be right. It's early in the morning here. You could hear dogs are barking, kids are playing outside in the neighborhood. And I'm not quite awake yet. So let's see if this actually works. We'll just run the tests. Let's see what we get. Seek optional failed, we knew. And our find test actually passed. Okay, so that once again is an explicit recursive solution, but let's do find too, right? And for maximum lulls, do we even need, well, we need to give that a name, and we're going to put list here and then we'll take it away later. So fold right, it's so early in the morning, I've totally forgotten what this is going to take. It's going to take an argument, which is going to be some lambda, right? Which is going to take some value and an accumulator. And then it's going to do something. And then we need an initial value, which is going to be, no, it's going to be empty, isn't it? Yeah, the initial value is going to be empty, because if we get to the end of our fold, we want to return empty. And then we pass in our list. Since we want to do this point free, we can actually remove those names, and it should still work correctly. He said optimistically. And then I think inside of our fold, it's going to look a lot like what we wrote in our explicitly recursive case. No. Else ack. Right, we just keep passing the accumulator back, right? Not sure if this works or not. Let's see what happens when we compile this. Well, it did compile. That's a really good sign. Let's try one of the success cases. That worked. That worked. How about something where we're not going to find anything? That worked. And let's try that infinite case. What was it? Find const true infinity or infinite? Infinity. We don't actually need that accumulator. And I just realized I have been this whole time testing the wrong function. I'm pretty sure it's going to work. This is a moment where people say something about Haskell, which is not strictly true. What they tend to say is, if it type checks, you probably wrote the code right. And I should have been testing this with my new function. I was testing it with the wrong one. But actually, when it compiled correctly, I was pretty confident that my implementation was correct. But let's just be bloody-minded here, and let's test with our fold implementation, just in case. Multiple declarations. Why multiple declarations? Oh, because I need to. That's interesting. I did not realize that the order mattered, that the patterns can't be interspersed through the file. I just learned something new. Equations for file. Because this one is trying to do it point free, and this one is not. So we can't do that. Okay. Okay, and let's run the tests with the correct capitalization. Bunch of failures. Okay, so now my implementation is not correct. I was very arrogant, and I was wrong. Interesting. So why is that? Oh, okay. I gave a big speech about how I didn't need to do this, but I did. So I think what's happening here, if we put this back, can I explain? Well, I'm just assuming that's going to work. And that works. All right, I'm being very silly. So the thing I'm forgetting is that this fold is operating on the entire list, including that nil. So pred nil is always going to be empty. And so that's going to go into the failure case here, which means it's going to, at that point, return empty. So essentially we're overwriting our accumulator from the right of the list. I think of it that way, fold right. And so in every case, this is the only time we're basically explicitly setting that value is going to be for things where the predicate passes. Otherwise, we just preserve whatever the last, I'm going to say the last true value, really the last true value or whatever we passed in. Length greater than 4. If we pass it a short list, we return false. If we give it any list greater than 4 elements, we return true. Unclear from this whether nil is considered an element here, right? Like if I were to return 1, 2, 3, 4 nil, is that greater than 4? Let's say nil is not an element, and we'll find out when we run the tests. We'll find out when we run the tests whether that's true or not. All right, it just takes one argument, which is the list. Let's use our Swiss Army knife here. It's going to be something, and our accumulator, we're returning some predicate. We're returning a bool, so it's going to be true or false, and it's going to take a list. All right, let's follow the types here. So fold right, something, false, right? Okay, we have a hole. That hole is some function that takes 2 arguments and returns a bool, where the second argument is a bool. Well, we know that second argument is going to be our accumulator. So let's go ahead and do that. Just call it hole. Now we got a lot of choices. We found a hole, and that hole has to be of type bool. And it's the first argument of fold right. And they're suggesting a whole bunch of things that this could be. And X, we know X is of type A. Interesting. So we don't know yet that X is a list. So this is an example where the point freeness is maybe hurting us a little bit. You know, doing this with a fold is silly because I think we can actually do this simply by pattern matching. Let's do that. That's a better implementation than this. So we've got our length, and the only thing we're taking is a list, right? So let's imagine that our list has 2, 3, 4. 1, 2, 3, 4, and 4 could be nil, right? And it has to be greater than 4, doesn't it? This is wrong, but I want to see what I get. Okay, length GT4. Right, false. What if 2, 3, 4, true? No, I think I'm going the wrong way here. 1, 2, 3, 4. Then we need an element that's greater than 4. And then we need, at last, our nil or everything added onto it. And those all pass. This one profoundly unsatisfying to me, but I kind of see how it works. I mean, it's interesting here because there's almost no code for this function, right? It's all the pattern matching getting you to where you want to go. All right, let's move on to reverse. Reverse is a classic job interview sort of question, right? And we can see here they're giving us a clue in the spec that it has to be performant, right? If we run this on a list with 8 million elements, it needs to be relatively quick. All right, so let's use our good friend fold right and see what happens. We know that those are arguments to fold right. We're starting with a list, so our first argument is going to be nil. What have we got? We've got an element of the list and the rest of the list. And we want to append that element rather than prepend it. So something like that. Do we have that defined? I can't remember. It's been a week since I looked at this. We do. Good. Is that correct? Will it type check? Let's see. Oh, I got a problem. Could not match expected type list A with actual type A. Oh, because X here is just our A type. So we can do that, turn it into a list. Okay. And let's try it naively. So the naive case works. Let's see what happens when we're in the tests. Uh-oh. And this is the case that I was worried about, which is we're basically hung because we're trying to reverse a large list. What is large list, actually? I'm going to dare. Let's see what happens. It's really big. Okay. So the issue here is that this right here, our append function runs in essentially, is it linear or quadratic time? I can't remember. But it takes a long time to run. So this isn't going to do it. So let's comment this out. So what can we do? So I think the real issue here is avoiding that append. We want to go through this once, if possible, and swizzle it. So if we go from left to right, can we do that somehow? Well, what if we use fold left? I think it's the first time we're using fold left. I believe we have to switch the orders of these. You know what? Let's have it tell us. And then I believe it takes that as an argument. List, a list. Yes, so my intuition was right there. And this is actually going to be a lambda, right? It takes a list and an argument, does something to it. All right. And that whole, I can reload, but it's just going to say that that whole is list A, right? List A. All right. So this doesn't actually help us know what the function should be. It's giving some suggestions. So if we were to put this together this way, I think that would be that would type check, but I don't think it would actually reverse anything. I think it would give us back the list we started with. Why does that work? It doesn't seem like it should work. Well, let's walk through it. We're starting on the left. We're getting 1. We're appending 1 to nil. Now we've got 2 coming out of the list. We're appending 2. That might work. Well, let's run the test and then we'll find out. Look at that. I've seen a variant of this that uses flip, which is a function that I could tell you the dictionary definition of flip. It reverses the arguments, but I never understand how to use it in anger. So I'm very happy that I've managed to come up with a solution that works here just by substituting fold left for fold right and prepending instead of appending. Produce an infinite list, in derision quotes, that seeds with the given value at its head, then runs the given function for subsequent elements. Well, if it's infinite, that's a clue that we need to use fold left instead of fold right, because fold right won't work on infinite lists. Fold left is lazy with respect to that. So what have we got? We've got a function. We've got a seed. And we're returning a list. Is this literally just going to be fold left? And our seed is going to be the initial value, right? Given value at its head. But it's a list, so it needs to be... No, that won't work at all, will it? Because then that would be at the tail of it. Oh, but it's just the accumulator, right? Yeah. So that's fine. And this is going to be accumulator. Well, what happens if I write this like this? No, because the accumulator, I'm getting myself all verklempt. Let's make sure, let's follow the types. H1 is ambiguous. Seems to me if we want to produce a list, we've got to seed it with a list, so to speak. So now it knows that H1 is a list in that case. So how about, all right, should be making these types more and more concrete as we go along. So now it's a list A. That's good. Where A is a rigid type variable. Seed is our type A. Function goes from A to A. So our ACC at this point is our list that we've passed in, which is a list that contains only seed. And so this needs to be a list also, which would be function seed nil. This feels overly complex, and this will fail, I think, in the same way that reverse will, in that it will be, for a large list, it'll be slow, but maybe we don't care if it's slow. Incorrect indentation. Mismatch. Oh, I am literally missing a bracket. Hate when the compiler's right. Fold left is applied to too few arguments. Right, because it's not applying to an already existing list. There's no way this works. I've got myself all messed up here. But let's try it anyway. Okay, that didn't work. How about this? Product. Can't spell anything today. The coffee isn't working. Okay, and it doesn't work. I'm completely barking up the wrong tree here. Let's forget about fold left. The derision quotes were a clue, right? The derision quotes are a clue because what's the definition of list? Let's go back and look at it, right? A list is a nil or something appended to a list, which eventually is a nil. But if this is an infinite list, there's no nil involved here. Even notionally, potentially, this could go on forever, right? So let's actually use explicit recursion for this. There is no situation where this will ever return nil unless the function itself. No, because the function is going to return A, not list A. So we're never going to return nil. Ever, 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 ever. Ever. So that means our list is seed appended to produce function seed, right? And what we're returning here, it's a list as far as the type checker is concerned. See, I don't see how we ever call that an actual list, though. It loaded. Yeah, the bit that is confusing me here, right, is at no point, I mean, unless, I guess take does. That's what's happening here, is take is doing some heavy lifting here, that if we looked at the implementation of take, it would be, well, when you get to the last thing you're going to take, that recursive case is a nil. And so it's kind of fixing, we're getting back a list, not really a list, from produce, even though it type checks. But then whatever we're doing on the outside of that call to produce is in fact what's fixing things up. Yeah, and it passed. And that is all of the tests in our list module, except for my nemesis, seek optional. I'm going to call it I'm going to pronounce it seek optional. And this one scares me. That thing, it scares me. So I'm going to give seek optional its own video. And you, my dear viewer, will have the distinction of seeing a grown man reduced to tears. So that's what you have to look forward to next time. Thank you for joining me on this Haskell for Dilettantes journey. You are watching Tea Leaves Programming. If you'd like to like and subscribe, that helps the channel. And if you join at an early access membership level, you get access to these videos before they're actually made public. We'd love to have you. Thanks for watching.